This is the server, or technically NAS device, that we have been using at Fstoppers for the last 4 years. Believe it or not, this thing has about 80 terabytes of storage in it. We also have an expansion unit, which is totally full as well. But as we hire more people and as we move to 4K video, this thing is starting to slow down. So the most logical upgrade was this. This is our new NAS device, or server, by Synology. But what makes this different, aside from its incredible weight and size, is that on the back are dual 10 gigabit Ethernet ports. Now, in all honesty, this server is probably overkill for you. It may even be overkill for us, but we needed more space and we wanted more speed, and this thing is all about moving over to 10 gigabit. We love Synology products because they are so simple to use. They have their own operating system called the Disk Station Manager that anyone can instantly figure out, and if you simply want more storage, this thing basically works right out of the box. But with DSM, you also have the ability to do so much more, including snapshot replication, automatic cloud backup, and you can even host your own website from it. Believe it or not, Synology makes a far more affordable unit that has all of these same features and still has 10 gigabit speed for a fraction of the price. We're gonna talk about that a little bit later in this video. Anyway, back to our build here. The first thing that you're going to have to do when you get any sort of NAS device or network access storage device is you need to install hard drives in it. And of course, because the thing is going to be running all the time, it's going to be accessed by computers potentially 24 hours a day, you want special high-end enterprise level hard drives. And Synology recommends that we use Seagate. So we went with Seagate IronWolf Pro drives. Seagate has partnered with Synology to create the IronWolf Health Management application that runs on the NAS itself. This application can access proprietary sensors in these drives to warn you earlier if the drives happen to have an issue. What's also cool about the Pro drives specifically is that Seagate will give you a 2-year recovery plan with those drives if you happen to lose data for any reason. So if one of the drives fails simply because it's getting old or it has a problem, they will pay to get that data back. Or if you have something like fire damage or water damage, they're going to pay to recover that data as well, totally for free. We decided to get some of the biggest drives currently on the market, and we installed 12 10 terabyte hard drives, which gave us technically 120 terabytes of storage in this unit. Now, to connect this server to all of the devices in our office, we actually need to create a network where everything is connected together. To do that, we need to use a switch. Now, we've had many switches that we've used in the past with our last server, but the issue is an average switch has only 1 gigabit speed. Being that this is a 10 gigabit server, we need a new 10 gigabit switch. I went shopping for switches and was shocked to see how expensive they can be, but luckily there is a relatively affordable Netgear version which we decided to buy. Now, to connect everything together, we need specialized Ethernet cable. You can't just use some old Cat5 Ethernet cable and expect 10 gigabit transfer speeds. So we ended up going online and buying 30 Cat7 cables. Now, the final piece of the puzzle is getting 10 gigabit speed into your computer. Most laptops these days don't have Ethernet ports at all, and although most desktop computers do, I haven't seen any besides the new iMac Pro that actually has 10 gigabit Ethernet natively installed. So we had to buy specialized PCI Express 10 gigabit cards for all of our desktop computers in the office so that the computers could actually accept the much faster 10 gigabit speeds. Now, before we permanently installed this entire system, we decided to plug the NAS directly into one of our computers, turn it on for the first time, and set it up. And we realized right off the bat there was an issue that we never expected. Okay, it's not as loud, but this thing is pretty loud. So this thing sounds like a jet engine. It was way louder than we ever expected. But before we did the permanent install of this, we decided to set it up, and we decided to use RAID 6, which would allow 2 drives to fail before any data would be lost. Now, looking at the pictures of this thing online, it doesn't look that big, and that's because you can't see how far back it goes. We just assumed that it was going to be about the same depth as our switches, and we thought it would fit in our current small, nice little rack. Well, it doesn't come close to fitting in our current rack. So we looked into buying something that actually could house this thing, and they cost more than the unit itself. So that was certainly off of the table for us. At the beginning, we just assumed, okay, we'll just stick it on the ground or kind of lean it up against the current rack that we have, because we don't need any sort of expansion ports for this at the moment. But the noise was really a problem. We don't have a door for the room that we wanted to keep this in, so we had to come up with another option. We ended up moving this thing into Patrick's home, which is another structure from this building. We ran cables to it to an area where Patrick keeps all of the security cameras, and that has worked perfect for us. Not only is it a large enough room to keep it nice and cool, but it also has a door that can close so nobody can hear this thing humming away, and it can make all the noise that it wants to. So then we started running Cat 7 cable all over our office and into Patrick's house, and we thought everything was fine until we booted it all up and tried to log in with all of the different computers, and we realized some of the computers were showing 10 gigabit speed and some were not.
I don't know if it's cheap cables, I don't know if it's the length of the cables, but it seems like the new Cat 7 cables that we bought, if they are 200-foot cables, will not transfer 10 gigabit speed. Half the cables that we ran were 200 feet and they do not work. So I'm going to have to return these cables. We're gonna have to go up in the ceiling, redo all of this.
So we went back online, bought more Cat 7 cable, and this time, before we ran it into the ceiling, we did a test directly from the switch into a computer to guarantee that we could actually get 10 gigabit speeds.
So the cool thing about this switch is we can just look at the colors and tell what speed it's at. So when it's green, we know it's 10 gigabit. If it's orange, it's just a single gigabit.
This one doesn't work. Cat 7 flat patch cord cable.
Oh my gosh, this is so crazy. I purposefully ordered a ton of different brands on Amazon, and I'm going to leave negative reviews for all the ones that can't actually do 10 gigabit, because I don't think it's really Cat 7 cable. I think it's all fake. It's a good thing we're testing this before we run the wires again.
Now, at this moment, we only have 5 devices that actually need to get 10 gigabit speed, and that is the 5 desktop computers that we installed the new Ethernet cards into. We have many other computers, including laptops that may or may not have Ethernet. We also have printers, and all of these things do not require 10 gigabit speed. So what we've done is we've used both of our switches, our new 10 gigabit switch and our older single gigabit switch. And what we've done is we've run fast Cat 7 cables with 10 gigabit speed from the new switch to all of our important computers. And then we've taken one Ethernet cable and run it into the old switch, and then from that switch we have run out to all of our other devices. By using both of these switches together, we can plug everything in that we need, but we didn't have to spend as much money buying a much larger and more expensive 10 gigabit switch. Now for what everybody has been waiting for. Let's do some speed tests here. But before we get into it, let me tell you the difference between a bit and a byte. If you transfer something to your computer or copy something from one folder to another or download something from the internet, your computer is probably going to measure that in megabytes per second or 1,000 bytes per second. 25 megabytes per second is 25,000 bytes per second. Some things though, like network speeds, are measured in bits rather than bytes. And there are 8 bits in a byte. It would be a lot easier if there were 10, but there's 8. This means that a standard Ethernet cable that is capable of transferring speeds of 1 gigabit per second is capable of transferring data at 125 megabytes per second. Luckily for us, in our initial test of the speeds of our old server, we were getting right around that speed, 100 to 125 megabytes per second. The new server blew our minds when it was able to download at over 400 megabytes per second. That is unbelievable to us because the internal SSD inside of our computers was actually maxing out. Those speed limitations are actually set by the motherboard and the SATA cable that is connected to the SSD itself. So we were super excited when we saw these speeds because we thought, oh my gosh, we are maxing out what this computer is able to pull. What we have to do now is pull from multiple computers at the same time and see if the server can keep up with these crazy speeds. So for the next test, we decided to pull the exact same file from 5 computers at the exact same time. We started with the old server, and just like we expected, instead of downloading at 125 megabytes per computer, all of that was split by 5. So we were averaging right around 20 to 25 megabytes per computer. So as you can see, with 5 or more people connected to the server all at once pulling data, you're really starting to share that bandwidth, and that's when things are going to start to slow down. Now, the new server should have lots of bandwidth to spare. So we did the exact same test, and we were shocked with what we found.
All right, we now have 5 of our desktop computers hooked up with 10 gigabit. We're going to drag over a 28 gigabyte folder that's on the new rack server over to our desktops, all at the exact same time, and let's see what speeds we get. Are you guys ready? Here we go.
So we all started downloading the same file, and at the beginning, it seemed to be a bit slower. On my computer, it was only downloading around 100 megabytes per second, but after just a few seconds, the speed started to skyrocket. Now, as I went from computer to computer, we didn't have consistent speeds over 400 megabytes per second, but I would definitely say the average speed for each of these computers was around 200 to 400 megabytes per second per computer. Absolutely amazing. Now, we've been using this system for about a month now, and one of the biggest time savers that we have found is the ability to upload almost unlimited memory cards at the exact same time without any sort of slowdown. Now, with our old server, if we transferred 2 cards at the same time, the speeds would be cut in half. And if we transferred 4, they would be cut down to 25%. So what this means for us, if we're out shooting a project, we come back and we have 10 memory cards to upload, we can actually upload them 10 times faster than we could with the old NAS server. Now, this server running RAID 6 gives us approximately 90 terabytes worth of storage, and we're estimating that that's going to last us around 2 years before we need to upgrade. Luckily, with Synology and this particular unit and many of their other much smaller units, when you run out of space, you don't have to buy a complete new NAS system. You can simply buy an expansion unit. So when this unit does finally fill up, we're not going to have to take it offline, we're simply going to add to it. Now, you may be watching this and saying, hey, 10 gigabit makes sense for f-stoppers. You guys have a lot of people accessing a server all at once. You need those super speeds. But what does this have to do with me? If you're the average type of photographer who's just taking pictures casually and editing a few pictures at a time, you're probably right and you won't see any sort of speed difference whatsoever. But if you start working permanently off of your NAS device like we do, if you start editing videos off of it, or you start uploading and downloading and editing weddings off of it, you will see a significant change in the speed because you will be getting internal SSD speeds while working on an external device. And you may be asking, well, why would I want to work on an external device? Well, there's 2 main reasons. One, you'll have almost unlimited storage when you work on an external device. And 2, you'll have the peace of mind that everything is being backed up and it is redundant when it's on the NAS. If you're working on a standard desktop computer, although you may have internal RAID, most people do not. And you could have a drive failure in the middle of working on a project and you could lose everything. So you're probably wondering, how in the world can I get 10 gigabit speeds for a reasonable price? Well, luckily for you, Synology just came out with a new, much smaller NAS device which only holds 8 drives. It's actually the exact same size as our older unit that we used to use. And this thing only costs $870, and it has dual 10 gigabit ports on the back. You're not gonna have to deal with any of the space issues that we dealt with. You're not gonna have to deal with any of the noise. This little unit is made for home or small office use, and you're gonna be blown away by the speeds that you can get out of this little thing. You probably also don't need as much storage as we do. So instead of buying the 10 terabyte Seagate Iron Wolf Pro drives, you may just want to get the standard Iron Wolf drives, and maybe you want 6 terabyte drives. You're going to save a lot of money that way as well. If you only have one computer that needs 10 gigabit speed, you may not actually need to buy a new 10 gigabit switch at all. You could run an Ethernet cable directly from the new NAS right into the new Ethernet port on the back of your desktop computer and get 10 gigabit speeds without spending that extra money. So now, with a fraction of the price of our insane server build that we have here at F-Stoppers, you're going to be able to get comparable speeds in your home office, and I guarantee you it's going to completely change the way that you work. If you're already in the market for a NAS storage device like this, I highly suggest going ahead, spending the extra couple $100 and moving to 10 gigabit. Single gigabit speed is on the way out. You want to future-proof yourself, and you want a device that you're going to be able to use for years to come. If you'd like more free content like this, you can always head over to fstoppers.com. And if you'd like to check out our full-length professional photography tutorials, head over to fstoppers.com/store.